Hello, excuse me. Who is we? Who is we?
Hello, sir. Vishnu.
Please put your original name, sir.
Okay, sir.
अभिषेक सर, आपने दो डिवाइस से लॉगिन किया है क्या?
नहीं सर, एक ही से किया।
ये अभिषेक कौन है फिर? एक और
दो अभिषेक है मेरे ख्याल से। एक मेरा नाम पूरा अभिषेक शेखर है और
ओके ओके।
Hello, audible?
Yes, sir.
Great. How are you? कैसे हैं आप लोग? How is your preparation is going on? So we have means complete first AC/DC network circuits in their series, parallel circuit and resonance we have discussed. Okay. Then we cover the DC machine. Now we move on AC machine. We discuss the three-phase induction motor. Please, in last time question paper, mainly the portion of DC machines are major, but this time please you have to focus on induction motor and transformer. alternator, because question will be asked from this time. Okay. So this induction motor is also known as a asynchronous motor. Why? Because it rotates less than synchronous speed, always. So see, this three-phase induction motor is has a it is so popular, because we have a AC generation. We have generated the electricity in AC form, alternative form. We can step up, step down. And it is commonly used in the industries. Okay, to drive, like what is the industrial loads? Maybe like lathe machine, blower, fan, pump. Okay. So the simple construction, high reliability, low cost, high efficiency. This is the cut section view. Okay, this is the squirrel cage. Now another type, it is a slip ring induction motor. Okay, it has a winding in rotor also. Now come to the construction of a three-phase induction motor. There is a main two part, stator, rotor. If we talk about the stator, there is a, see this outer frame, it is a casted, but this inside has a laminated core. That is, it is a laminated silicone steel core, which has a inner periphery has a slots. In that slots, we do the winding, three-phase winding. Distributed three-phase winding. Okay. Now come to the rotor. So as discussed, the rotor is squirrel cage, but other type of, we also use rotor, because squirrel cage has some disadvantage, means not disadvantage, limitation. What is the limit? It has a low starting torque. So to improve the starting torque, we use a different type of rotor, like slip ring, or it is a wound rotor. Second is deep bar rotor, or maybe double cage rotor. Okay, so there was a one question, it is asked in your exam also. I will show you the question paper questions which was asked in your this. Because we should know the question, so that we prepared according that only. Because, but as a vast topic, every topic is vast. So we have to limit our syllabus as per what they ask. We go on that. See, these are the questions from your three-phase induction motor. Okay, three-phase induction motor question. This recently asked. Recently means from August 2020 onwards, when pattern is changed. Okay. Hello, are you comfortable with this written class or not? Because hello, you are enjoying or not this lectures? Please.
Yes, sir.
Great. Thank you very much. Now we will continue. See.
Yes, sir. Yes, sir.
Before we proceed to the answer, lecture, we have to learn the questions. Means what is their approach. Explain the matching of an induction electric motor to a pump requirement for man circulating duty with the aid of pump characteristics, torque and slip diagram. Okay, so means they asking you have to select a motor for a pump. Okay, for duty means circulating duty means it is a flow rate. Okay, so see now some type of design question will ask same like in your see that what is the question which ask for blast thruster pump motor. You have to design the switch gear, cable and motor protection. Same like here they ask the motor design. What are the causes of overheating of an induction motor? You have to write the causes like due to under voltage, due to single phasing, due to overload, correct? Or due to bearing jam, bearing problem. Okay, these are the main causes of overheating of induction motor. Got it? What are the preventive measures are provided against damage to an induction motor in installed condition? Preventive measures provided against damage. What are the preventive measures in installed condition? So it is indoor, outdoor. We have to put the enclosure. We select the enclosure according to that installation. Then there is a like there is a IP interest protection code. The standard we use what is your this IP protection code and other is from overload, short circuit, under voltage, overcurrent, temperature monitoring also in the large size motors. We monitor the winding temperature. We insert the thermocouple in the stator. We can measure. These are the preventive measures we have to put on an induction motor in installed condition. So basically motor protection. Okay. What are the purpose of fuse backup protection provided in in an induction motor? Okay, so like there is a overload, under voltage, these relays are there. Okay, overload protection is there, but we also use a backup protection. If suppose your overload relay not trip, not protect, then your fuse will prevent the motor from excess current or overheating. Okay, so we use a backup protection as a fuse backup. Okay, how does an induction motor develop the torque? How is the torque is developed? Like it is a sometimes this question can be asked working principle. It is the same. You can write working principle of three-phase induction motor. Same answer you write for that. Means when we connect the three-phase motor with a three-phase balance supply, the three-phase flux set up in air core, resultant of this flux is will be rotate in the air gap with synchronous speed. Now when your current carrying conductor like your rotor bar, rotor conductor placed in magnetic field that experience a force, means this flux is linked with the rotor bar, rotor conductor. Now current is EMF is induced, then they are short circuit at both ends, then current will flow. Now when a current carrying conductor placed in a magnetic field that experience a force, so one torque is produced that turn the rotor in the same direction in which your rotating magnetic field is rotates. How the rotating the torque is developed, we can write. Now, what are the conditions to be satisfied for maximum running torque? So we have to running torque. It is not starting. Maximum starting torque is different. Maximum running torque. So under when motor is running with slip S, then what is the condition for maximum torque? Your rotor circuit resistance equals to slip times of rotor reactance. Correct. This is the condition for. So just they asking the condition of maximum rotor torque. So this question 2 is also very simple. You write the point-wise answer. Because 5 questions they ask in a 16 marks. Okay. One by one, you have to reply. Now next is list the factor that determine the starting torque of 3-phase induction motor. How does this torque is generally compared with a rated torque? You have to write the your torque equation. Then at starting, what is the torque? It depends. Then you compare with full load torque, rated torque. Okay. So generally, starting torque is higher than it is 150 or 200% of rated torque. Then there is a one numerical. This on 3-phase motor. Then for the describe the possible causes and the effect of running a 3-phase motor with one phase open circuited. So if one phase is open circuited, that is condition. It is called as abnormal condition. This abnormal condition is known as a single phasing. Hello. If one phase is absent, means motor is run. One phase open circuit means motor is running continuously on 2 phase. That it is an abnormal condition, like under voltage, overload. What are the abnormal conditions? Hello.
So motor takes
Just a minute. Abnormal conditions for motor or any electrical. First is like under voltage, overload, short circuit. Okay, like it is for motor also. Abnormal condition, under voltage, overload, short circuit.
Unbalanced winding.
Yeah.
Unbalanced winding.
imbalance current.
Yeah, imbalance in current. Yeah.
Overheating producer.
Overheating. So one is the single phasing is also there. Single phasing. You have to list out in here which causing of overheating. Under voltage.
Sir, vibration is given or also abnormal sound or vibration.
That is that is abnormal means operation. Okay. Yes. So now here is one thing is they ask that is called single phasing. This single phasing. So we have provided this in a large motor. We prevent this single phasing. Generally, we have a single phase preventer. What we provide? Single phase relay or preventer. Okay, which protect or prevent the motor from running on a 2-phase continuously or in single phasing condition. So motor will trip if it is operate on a single phasing. Okay. Correct. So he asked what is the possible causes and effect. What is the causes? Causes means how it is. Suppose one fuse is gone, or your maybe what is the causes of means this single paging.
Contactor is faulty.
Yeah. Hello. Suppose it has a star delta or a dual starter, then suppose one phase fuse is gone. Okay. Maybe your one phase breaker is not closed properly. One pole is open. Correct. Okay. Maybe terminal is loose of that particular phase. Then this is the causes of single phasing. Means one phase is open circuited. Then what is the effect? If suppose motor is run on a two phase continuously, then if motor at some time it will trip due to, because it is like a similar to under voltage also, because net voltage RMS value of voltage like it is 415 volt when there is a three phase balance supply. Correct now? R, Y, B, all three phases will be there then. See, this is when all phases present. Correct? So this is the your each phase flux. Suppose phi R, phi Y, phi B. Okay? But suppose B phase is gone, then this motor has only two. Then you are, we're talking about resultant flux in the air gap, resultant magnetic field. That is 3/2 times of maximum flux per phase. Like there has a phi R equals to phi M sin omega t. There is a all three phase develop flux R, Y, B. Okay, it is phi M sin omega t plus 120, or this is phi M sin omega t plus 240. Correct? Okay, so this resultant of this all three in the air gap is this value. But if suppose this phase is absent, one B part, okay, if it is not there, then only two phase flux. Then see, their magnitude it is a constant magnitude. But if only two phase, this is not a constant. Okay, then your torque produced by motor is directly proportional to this flux into rotor current and rotor circuit power factor. So if your flux is not constant, then motor does not develop the constant torque. So it is pulsating. Like see, when they are opposite, this phase to phase, then there is no flux, zero, opposite. Then motor is get a jerk also. And see another case, so it will not develop a constant torque. Okay. Then if suppose there is a load on the motor continuously, okay, this is the motor, there is a load. So this is get heated due to this, because it required it not get a rated voltage when one phase is absent. Okay. Second, another thing, when only two phase, there is a negative sequence component will come. Negative sequence harmonic is increased. So there is a negative flux in the air gap will become negative sequence harmonic flux. Due to this negative sequence, the slip is double, 2s. Then rotor copper loss will be, rotor copper loss, we will discuss, that is slip times of rotor input. So this rotor copper loss will be double in that case with respect to this negative sequence component. So means sometime this question is also asked in objective type. Okay. So during single phasing, which part of motor is damaged due to overheating? Hello.
Winding.
No, stator winding. Rotor will damage effect actually measure. Suppose this phase is absent. Because rotor copper loss will be more. Actually, rotor copper loss will be double in that case. Stator also get a more current, okay, but more losses in the produce heat in rotor also. Correct. Then rotor will burn during single phasing. Okay. Okay, dear. We have to prevent the motor, that's why, from single phasing. Okay. This is the question. Huh? Now you keep in this mind these things. Okay, let us we go. Well, another question was also there. Here it is not there. Yes. One is also there, one question. And then only. सर वो एक क्वेश्चन और था इसमें that how to improve the torque of, I think it is in October month or August. Starting torque, how does the torque is generally can be वाला है. Yeah, this one in August month. The soft starter question also you consider in motor. Describe how the starting torque of an induction motor is improved by using wound rotor, double cage rotor. So this is also a question, please. And soft starter. Advantage of soft starter. Okay. So this question you also add in this. Okay, I will. Correct. Here the two type of rotors generally here, so mainly two types, squirrel cage and wound rotor. Now we have to improve the design in the squirrel cage by providing a double cage, okay, to increase the starting torque and reduce the starting current, okay. Now come to here, two type of rotor. First is squirrel cage rotor. In squirrel cage, just we laid the copper bar or aluminum conductor bar in the slots, outer periphery. See, rotor has a slots on outer periphery. Stator has on inner periphery, okay? And this conductor short circuited by both ends by shorting rings. But now see, in wound rotor, please. In wound rotor, not bar. do the winding, three-phase winding, similar to stator. And that this rotor winding is always connected in a star. And that end of this rotor wires are connected to 3 slip rings on rotor shaft. External resistance is connected in each winding at starting. See, we also connect the resistance. We add the resistance during starting. So that it reduces the starting current and improve the power factor. And higher rotor resistance at starting increase the starting torque also. When motor get started, means get a speed 80-70%, then this external resistance is cut. Finally, your rotor gets short circuited. Okay. This is your slip ring or wound rotor. So here in wound rotor, there is a 2 terminal. One is stator, other is rotor also. Rotor terminal go to your rotor resistance starter. Okay. This is the comparison in squirrel cage and slip ring. Okay. Mainly squirrel cage motor is superior than slip ring, but only it has a low starting torque, low power factor, and high starting current. Mainly these two, 3 and 6. Okay, this disadvantage are improved in slip ring motor, but slip ring motor has a higher cost, more maintenance required. There is a sparking, the slip rings are required. Okay, got it? See, generally, if we talk about 3-phase induction motor, so there is a first part is your stator core. This is the stator core. In this stator core, there is a slots. In that slot, we do the distributed winding. Okay, winding is carried out here. Stator 3-phase winding. Then there is a rotor. This is the shaft. In rotor, outer periphery. And now here bars are put in squirrel cage, like these bars. Now these bars are short circuited with end ring like this, copper ring. Okay. So here when we put a 3-phase supply to stator, then a magnetic field is developed in this ear gap. So this is a stator and rotor, 2 major part. In between there is a ear gap. In ear gap, this is your ear gap. In ear gap, there is a magnetic field fire is developed. This rotated with synchronous speed, ns. Okay. Now, when it rotates, it cut by this link with this rotor conductors. Okay. Then in half portion, the current is inward. In half, current is outward. Okay. Then there is a torque is produced. Hello, this way and this. Then it is start to rotate, but less than synchronous speed n. Here it is synchronous speed. Okay. This is the synchronous speed. Correct? So if we see this stator has a generally either star or delta connected. Okay, stator winding generally either we connect in star or delta. Like this is your motor stator winding. This is your stator. Okay, dear. This is your three-phase AC. We apply R, Y, B. Okay, dear. Then due to this take a individual phase current, no, IR, IY, IB. Okay. So due to this current, there is a flux is induced in these three windings, all three windings. Okay, phi R, phi B, and phi Y. Okay. If we see now, they are at if balance AC supply is put here, then there is a balance three-phase torque will be balance three-phase flux will be produced. Okay, like this. Okay, this is your magnetic phi R, phi Y, phi B. Okay. Now the resultant of this all three flux, that is at 120 degree apart. If we calculate resultant of this all three, we split into horizontal and vertical component. Horizontal and vertical component. Then we calculate their resultant. Okay, like this. We resolve this all three into horizontal, vertical, then we get a resultant flux phi R. And this phi R equals to nothing but it is 1.5 times of phi M. Phi M is the, this three-phase flux are like RYB. This RYB, like they have like this. Hello. This three-phase current, this three-phase RYB has a three-phase like this. Okay, this three-phase flux RYB. The resultant of this will get this. Okay, and this is the maximum. Phi M means phi M per phase maximum flux. Okay, so it gives the constant value. Correct, which rotate in the ear gap, appear in the ear gap. Okay, now squirrel cage rotor is this, represented by this. Okay, this is your rotor, squirrel cage. Okay, this is your rotor conductor. This is your squirrel cage rotor. Now see, the resultant flux is produced here phi R, that rotate with synchronous speed. Now there is a current is induced in this conductor, some like this. Okay, in half this and in half inward. So there is a torque is produced like this way. Okay, then it start to rotate in same direction but less than this synchronous speed. Got it? This is your squirrel cage, but in wound rotor, this rotor has a three-phase winding which is star connected. So suppose stator either a star or delta connected. This is your stator. Okay, generally we have a delta connected here, RYB. This is stator. Hello, stator either in star or delta connected, but if you are wound rotor, then it is always connected in star. This is your This is your rotor of wound rotor. On this same shaft, there is a slip ring. 3 slip rings are there. Now here there is a external resistance. Okay. Here 2 positions, running, starting. Under running condition, this starting condition, this resistance is connected in series with this rotor. Under starting, maximum resistance come in series with this windings. So these are the slip ring and brushes we have to put here. Brush, okay, brush, contact brush, okay, carbon brush, okay. Now this has a winding connection like this. Okay, dear, this is your rotor, wound rotor, okay. Correct. Now, what is the comparison here? See, I will explain in a simple word. Here, the rotor conductor are bar, like thick bar. These are the rotor conductor. Now, their length is short, cross-section area is large, area. Then resistance R2 is L by A. No? So if length is short, area is large, then resistance is low. That's why this squirrel cage has a low resistance. And please remember, this torque is directly proportional to the rotor resistance. When we drive the equation, you definitely come. Or simply you write, power factor of rotor circuit is rotor resistance by rotor impedance. So if power factor is high, means torque is high, because you know torque is directly proportional to phi r I 2 cos phi 2. Okay. Here resistance is high, power factor is high, means torque is high, or it is torque is directly proportional to rotor resistance also. Okay, please remember. So here, because resistance is low here, that's why torque is less in squirrel cage. But if talk about this here, this winding has a thin wire and long length, thin area. So it has a, R equals rho L by A, large, has a high resistance, rotor resistance. And we add the resistance also. So in R2 and at starting, what we do? We add the external resistance also. So this per page, this resistance is more at starting. Then this has a high power factor and torque is high. Okay. Now you know power factor is high, torque is high. Now resistance is high. Then see, please, I will per phase. Hello, if we per phase draw the rotor equivalent circuit. Hello, in rotor there is a rotor resistance. Due to this winding and core, there is a rotor reactance also there. But it is variable because it depends on slip times of R2. This is R2. Okay. I will explain. Here, this is the induced EMF in rotor. Now I will tell you. See, please do not take it is a hard. It is very easy. That's why we cover first the RLC circuit. It is a RLC series circuit. Okay, this is R, this is X. Now you can calculate the current R2, I2. Hello, please rotor current. You please write the rotor current. What is the rotor current here? Tell me. I2 equals to generally
S2
applied voltage, means induced voltage by impedance Z2. Then rotor circuit power factor that is cos phi 2. This also resistance to impedance. Always it is a, this is suppose your resistance of rotor, this is reactance, then this is impedance, this is R2, this is XX2, this is Z2, this is phi 2. Then cos phi 2 is this, means now Z2, please, Z2 is your impedance, R2 square plus XX2 whole square. Okay, any doubt? Here this in rotor circuit, this is your rotor circuit. Okay, now my dear, see, due to high resistance at starting, the impedance is also high, then rotor current is low because it is XE2 by under root R2 square plus XX2 whole square. R2 by okay. So see, resistance is more because at starting overall rotor resistance is high because here we add the resistance also. Then see, in wound rotor, power factor is high, current is low. That two things we want to improve. Na? We want a higher power factor and low current. And now torque, as you know, torque is phi R I2 cos phi 2. Or very simple, na? Torque is depends on directly proportional to rotor resistance also or power factor. Okay, so means there is a high starting torque. Okay, this 3 parameter here is low. Why? Because resistance here is also same circuit, but here these are the low resistance, means low impedance. Okay, that's why current is high, power factor is low. Got it? Important comparison between wound rotor and squirrel cage rotor. Now you read. This is now clear. You enjoy. Means you get understand. See, construction is simple, low cost, but less starting torque. High efficiency, why? Because under running condition, when motor is running, there is a rotor resistance is low because there is a bar, then low copper loss. That's why efficiency is high. But here starting में low power factor, high starting current. But there is no slip ring and no sparking, low maintenance. Okay. Here cost is high, construction is complicated. There is a sparking on brush, low, higher maintenance required. But it has a high starting torque, low high power factor at starting and low starting, means starting performance is good for slip ring. In starting, what we want? High starting torque, low starting current and high starting power factor. These three things we get higher in slip ring, but in squirrel cage they are low. That's why we improve their means change the construction. Like we use a double cage rotor. How we make the starter. Okay, it is a single lamination. Then they stack together. We make this. Then we do the winding. It is fixed in the yoke. Then see starter winding. Now squirrel cage rotor, wound rotor. Okay, this is when we remove the iron part, then your copper part means conducting part is this rotor. Hello, this is like it seems like a cage. That's why it is a squirrel cage. This is the ring and rings. And these are the bars. It is a squirrel cage rotor. Conductor part in which current is flow. Okay. Now on stator we have a terminal box here. 6 terminals are come. Then we make the connection here star or delta. Okay. And in star delta starter, in dual starter or BFD, we have a fixed connection like star or delta. But in star delta, there is a in starting we start the motor as motor is connected in star. When it get started, means get a speed 80% or 70%, the transition is means winding connection is changed to delta. For that we use a 3 contactors. You know, this all 6 terminal be brought to the motor lock, your starter panel. Hello. There was one practical question. Okay. When we connect the motor, suppose this is your starter panel. This is your starter. It is dual starter. And this is your motor. So this motor is connected. We required a 3 core cable. Oh, correct, na? 3 core cable like this. 3 core cable. 3 core means 3 single core cables or either a 3 core. This is which required a 3 core. What is it? Is maybe what is the size? 10 square mm, 5 square mm copper conductor, like this. 3 core single run. 1 into 3 core. Okay, in VFD drive also, when we have a VFD, we also require only 3 core cable. But in case of star delta, if here it is a DOL. But if you have a star delta starter, then this is your motor. We required a 6 wires, means 2 into 3 core cable to run. Here it is a single run of 3 core cable. Why? Because these 2 cables brought all 6 terminals this 2 and this 2. So this from this terminal box, this all 6 we come here, and the conversion of star delta is take place in the starter. We use either automation, we use a time delay relay, okay, for that. So this is another disadvantage of star delta. Here two run of cable is required. Here is in VFD or star delta or shaft starter, we require a single core, means single run. There is a cable installation, cable cost is reduced. And when there is a star to delta conversion, when transition time, this motor does not get the voltage, and suddenly your voltage is multiplied by √3 times more as compared to star. Okay, correct? So this motor get a jerk. This is the disadvantage, limitation of star delta. That's why we go for a VFD or shaft starter. Okay. This is the starter part we discuss later on. Okay, but this is the discussion because here connections are so this all 6 terminal. Okay. This 6. These windings are inside the your motor starter. Now these 6 are come in your terminal box. By using this 6 terminal, we make a star or delta connection. So like it is U, V, W, U, V, W. Now this is U1, V1, W1. This is U2, V2, W2. So if they connect in delta, now starting end to finish end, starting end to finish, starting end to finish, and here like, and we give the supply here like this. Or if they are in star, okay, so we short this and we give the supply here. So it is star connection, this is delta. Okay. Now how the torque is produced or rotating magnetic field is produced in a air gap. So when we at balanced three-phase supply is connected to the stator, a rotating magnetic field of constant magnitude is produced, which is rotate in the with synchronous speed in the air gap. Okay. So that is speed is given ns equals to 120 f by p. Here f is the supply frequency, p is number of poles. So see, this RYD position are changing with respect to time. This is all RYB. This graph is show the your three-phase flux, magnetic flux produced in air gap. So their values and direction are changed continuously. Please observe RYB color code, and this black one is show here in motor side, resultant one. So see, always when suppose there R is absent here. Why? Because suppose it is passed through the 0 point here. Okay. Then also due to Y and blue, the magnitude is same. And position is also changed. Like see here. See RYB you observe. Their magnitude and the direction are continuously changed. from their magnitude, we calculate a constant magnitude, but the resultant phasor, black one, is continuously shifted. Okay, and that shifting is appear as like a rotates. Actually, it is not rotate. Magnetic world is not rotate in air gap. Their position is changed, which is high means speed 120 f by p. That speed is called revolutions, okay, or in RPM, cycle per second. Okay. Now it depends on the number of poles. Your stator is designed for pole, with like 2 pole, 6 pole. Generally 4 pole, 6 pole, 8 pole, okay? And in 50 hertz system or 60 hertz system. So suppose you take a 4 pole, in 50 hertz you have 1500 RPM is a synchronous speed, but in 60 hertz it is 1800 RPM. In 6 pole, 50 hertz system you have a 1000 RPM. In 60 hertz system it is a 1200 RPM. Synchronous speed, okay? Now here, now your motor, because torque is produced, then your rotor is free to move because it's mounted on the bearing. When torque is applied, it start to rotate. But it start in rotate in same direction, but less than the synchronous speed. Therefore, the difference between this synchronous and actual rotor speed is represent or expressed as a percentage of synchronous speed. ns minus n by ns, that is called as a slip or percentage slip, okay? Now, actually now we can compare the three-phase induction motor with the three-phase transformer. There is a similarity. First of all, we put as a point, what are the similarity? Like in transformer, there is a 2 electrical circuit. Here also, stator, rotor. There is a primary, secondary. Now, common thing is there is a constant flux in the core, transformer core. Here, constant flux in air gap. So these two circuits are magnetically coupled, link, same like a transformer. Now, power is transferred from primary to secondary in transformer. Here is power is transferred from stator to rotor. Okay. We can say like your three-phase induction motor is like a three-phase transformer with short circuit secondary, because your rotor is like a short circuit secondary, okay? Now, but your transformer secondary is not rotate. Similar to three-phase induction motor, your transformer secondary will also start to rotate, but then not rotate. Why? Because in transformer, primary and secondary mount on the same core. Here, stator, rotor are different core. Stator core is different, rotor core is different, and there is a air gap between that. In transformer, no air gap. Okay. Now, in transformer, the EMF or power is transferred to one circuit, means primary to secondary at same frequency, constant frequency. If someone is asked what is the frequency of induced EMF in the secondary of transformer, same like a primary, means 50 hertz means 50 hertz. Okay, but in induction motor, the frequency of induced voltage in rotor, it depends on slip. Okay, so it is a slip times of stator frequency. Please remember, rotor frequency is equals to slip into stator frequency. Okay, this is important. Now equivalent circuit and this. Important definitions or either notes you can say. First of all, synchronous speed, ns, rotor speed or motor speed. Okay, slip speed, then percentage slip or simple slip. Okay, frequency of rotor EMF or rotor current. This is the speed at which the resultant magnetic or resultant stator magnetic field. Resultant stator you write as field. Rotates. Okay, that is called synchronous speed, and it is given by ns equals to 120 f by p in rpm. Sometimes we can calculate into rps also. So small ns equals to capital Ns by 60. It is in rps, revolution per second. This is revolution per minute. Sometimes it is right like this. It is rpm. Okay, revolution per minute. Okay, now there is another this synchronous speed we can represent by omega s also. That is 2 pi ns. This is also a synchronous speed, but it is in radian per second. Please know, this is all our synchronous speed, but it is in rpm, this is in rps, and this is in radian per second. Okay, now here we write f is the in this formula. Okay, frequency of supply frequency, stator frequency. In hertz, and p is the number of stator pole pair. Okay, now this is actual motor speed at which rotor is rotates. speed, and this is always less than the synchronous speed. Okay. Now slip speed. This is the difference between synchronous and actual rotary speed, but its unit is also RPM. Okay. Now when we calculate a slip, if we represent this difference with respect to synchronous speed, it is called as a slip. In percentage, you multiply by 100. Or simply slip we can represent ns minus n by ns. Now we can also calculate a slip, ns minus n by ns or omega also, because it is a ratio. Same value will come. Okay. Now we take this side, so it is n SNS equals to ns minus n. Now this part we take this side and this we bring to this side, then n equals to ns minus SNS, or n equals to ns 1 minus slip. So this is your actual rotary speed. Actual rotary speed n equals to ns into 1 minus slip. Please remember. Okay. Now, this is called as a slip speed. So this ns minus n means SNS. It is the slip speed. Okay. This is percentage slip. Now frequency of rotor circuit is FR equals to slip times of supply frequency, stator frequency. Okay. Any doubt here? In earlier old question papers of ETO, there was some questions on this also. अच्छा ये इधर डाले हुए थे, ये क्वेश्चन मैं उधर शिफ्ट कर लेता हूँ ना, कॉपी। Okay. Third onwards, these are the old issue question. In the old pattern means That time simple questions was asking, like a short note on principle of operation of motor. What is the slip? A 6-pole motor supply with 60 hertz, run with a slip 5%. What is the actual speed? Then construction and working principle of three-phase motor. Now with reference to three-phase induction motor, you draw the circuit diagram and explain the working of star delta starter. So here you draw the power circuit diagram of star delta. In second question, ladder logic diagram. It is sometimes different question is asked, okay? And their advantage, disadvantage of star delta. Explain with the diagram how the direction of rotation of single phase motor is reversed. Now another question was asked this time from a single phase motor, how we improve the starting torque in a split phase motor, or either a split phase resistance split has a resistance is split phase and capacitor is split phase. Then capacitor is split phase start motor has a high starting torque as compared to resistance split phase. What is the reason? This question is recently asked in your exam, I think in January month. Here.
Sixth question maybe.
Yeah, capacitor start induction motor has a much higher starting torque than resistance split phase. So this is the question from single phase induction motor, okay? So there is a resistance split phase, capacitor start, capacitor run, different type of motors, no? And this question is also there, we discussing here, how the direction. So there is a two winding in a single phase motor, you know, as a simple single motor is not a self start. So by split the phase, we can make it self start. So there is a two winding, main winding, auxiliary winding, or running winding and starting winding. So how we reverse the direction? In three phase, we by phase sequence. By changing the phase sequence, we can change the direction. But in single phase,
changing the capacitor connection, sir.
Changing the
Capacitor terminals opposite of.
capacitor means auxiliary winding connections.
Yes, sir.
Either we reverse the running winding or means main winding or auxiliary winding. But mostly we prefer in which the capacitor is connected. Suppose it is a resistant split phase. Here it is not asked, it is a capacitor start. Maybe it is a simple resistance split phase, means single is there is no capacitor. So either we reverse the polarity of starting winding or running winding, means main winding or either auxiliary. Okay. If you reverse the polarity at supply terminal, phase neutral, motor will run in same direction, no change. Only one winding we have to reverse. So generally we prefer a starting auxiliary winding because there is a capacitor is connected, okay? Correct. Second, like in DC motor, DC motor, how we reverse the direction? Same. There is a two circuit in self start or either separately. Either you change the polarity of armature terminal or either field terminal. If you change the polarity na positive negative at main terminal, the motor will run in same direction. Only one, either a armature or field. Okay. Hello. Next is same like here. This is the very simple questions on speed. Okay. You can solve like hello. This 4-pole 3-phase induction motor operates from a supply 50 hertz. Now first question, speed 7th. I am talking about 7th. The speed at which field is magnetic field of stator rotate, that is synchronous speed. It is 120 F by P. You have a pole frequency. Then speed of rotor when slip is 4%. So N equals to NS. Now NS you calculated, no? It comes 1500 RPM. Then 1500 into 1 minus 4% means 0.04. Then frequency of rotor when slip is 3%. Now you use a 3% slip. So 0.03 into F, 50. Got it? Very simple. Same eighth question also. These are asked earlier. Same like 9th question also. Okay, this 9th, 8th, 7th, same things like speed related. Then losses efficiency. So tomorrow we discuss. Okay. Correct?
Okay.
Okay, tomorrow we will solve the questions. Okay.
Okay, sir. Thank you, sir.